Good afternoon, everyone. Thanks for joining. I know this session was announced late because it was embargoed until our CEO, Andy, announced it yesterday. So thank you very much for taking time again, and hope you have had a good show so far. So since you're here, I've spent a number of years doing IoT solutions, and what I've learned through this year's IoT, it has 3 phases roughly. So the first phase that I tackled, and then some of you in the room may have also experienced, is how to securely connect the things, and what protocols for the cost of the solution, what can I actually afford to put it in the system, and then how do I securely connect? And that was a big challenge, but largely due to innovation in the silicon products, we have a partner from Intel, and I used to work for Intel. So semiconductor companies have reduced the cost and the size of these things to fit in any places. So it's largely very easy to connect. Second phase is, okay, once you connect it, what do you do with them? And is it the fixed function from the day one to the life of this cycle? But obviously you want to update them and program them. So programmability becomes challenging. You're a cloud programmer, you don't know how to program the embedded side, and if you're an embedded programmer, you don't understand what the cloud is. There are silos. So that was the second phase, and I'll talk about it, what we have done there. But the third phase is, yes, even if you can program it, but that requires the intervention of programmers. And then the third stage of IoT, what I call it, autonomous system, that learns what the behavior it needs to learn and then program itself. Anyway, so my name is Satyen Yadav, and I'm a general manager in AWS, and I'm responsible for IoT Edge and Device Services, along with Jason Chen, my colleague, who's a principal product manager on my team, will help you, will walk you through what we mean by pushing the intelligence at the edge. So let's see if I get the clicker right. Okay, so I wanted to give you a little bit of background of how we got here. So before I get there, how many in the audience have heard the name Greengrass? Okay, so I'm in front of a friendly audience, it seems. So last year, if some of you are here, we tackled the second challenge I talked about, how to easily program the devices. And so last year's state was, before last year, we had a service called AWS IoT, which is ran in the cloud. And we extended that service to using Greengrass. So Greengrass consists of 2 major things. One is the AWS IoT core system that's now can run on a local connected device. And then second thing is you can program it, what we call the Lambda functions. So together that we made it easier to connect lots of devices locally, run this system locally also when it's not connected to the internet. The key theme that I talked about is having a common programming model across the 2 silos, if you will. And so today we support Python, Node.js, and Java as a programming language that you can write the code in the cloud and also write the code for the device. So that was the state of our affairs last year. So this year, and some of you may have been in our CEO's keynote, so this may sound familiar to you. So this year we are extending number of services both in the cloud and then also talk about what we are doing on the edge. So starting in the cloud, the first service that first functionality we are extending in the cloud is to let you manage fleets of your devices. So if you have large amount of devices, how do you logically group them? How do you update them? And how do you keep that system up to date and manage it? And so we call it IoT device management. The second service we announced is once you have this large fleet of devices, how do you audit them, make sure they are secure, how do you protect them? And so the service called IoT Device Defender, that's the second service which will be available next year. And finally, on the cloud side, once you connect these large amount of devices, how do you take the data from those devices, make sense out of that data? So to do that, taking your raw data, formulating and filtering it, and making it available for analysis, visualization, and then taking that insight out of that system and use this to update your overall IoT setup. And that's called IoT analytics service. so that was on the cloud. But one of the other things we did, we announced earlier this week, is Greengrass is this service that runs on a CPU class device or Linux class device, where you have sufficient amount of compute power, memory. But what about sensors, which are runs on typically on microcontrollers, do not have enough resources? For that, we announced Amazon FreeRTOS. FreeRTOS is #1 microcontroller operating system. What Amazon has done is made it a IoT and cloud native, if you will. So connectivity, security, having it either work directly with the AWS IoT core, or in this case, also connect to sorry, didn't mean to go this way. Okay, also connected to locally to the Greengrass. So what we have done is if you have constrained devices running on a microcontroller, now you can use FreeRTOS as a complete solution to quickly connect that. Now, for some of our customers, this whole thing is still very complicated. And they have a simple application. They want some trigger, physical trigger that is a button, motion, or any number of other sensor trigger that they want to notify and then take action based on that. For that, we also announced a service called AWS IoT One-Click. And the way it works is there are a number of devices that are compatible with this service. So you pick a device, whether it's a button or a motion sensor. You select what action you want, either a email notification, SMS, or actually creating a ticket in a Salesforce or in your enterprise application, any number of things. So if you could write a Lambda function for whatever you're imagining, you can actually invoke that by a simple trigger or simple action from these devices. And then simply you use the report. And so the idea here is that there's a number of customers who do not understand either how to build the device, how to have the embedded systems, or cloud services. For them, this is an end-to-end solution. So that's the state of affair for us at this moment. But this session is about intelligence. How we talked about the third stage of IoT and how do we actually take the first step towards building those autonomous systems. So how do we do that? So before I get there, I wanted to touch on within the theme of extending intelligence to the edge. We announced a number of features, new features to Greengrass. These are the features probably you're familiar with. You can run the Lambda function. You can trigger devices to invoke through the local messaging, local processing, local device shadow, and sync with the cloud, and also the security, as Greengrass runs its own certificate authority, and it can manage all of the security locally, as is the same principle as we have in the cloud, that you have X509 certificates, and the whole certificate management is also done at the Greengrass. Now this year, in this conference, we announced a number of other additions to Greengrass. So first one is over-the-air update. So Greengrass code today, you have to deploy it, and then if there's a new version, you have to find another mechanism to get it updated. With over-the-air updates, you could actually set up the automatic update of Greengrass core. When there are new bug fixes or security patches are available, you could set up this system automatically up to date. The other request we get from customers is the number of local protocols that needs to interact with the local Greengrass device locally. So we have created a framework, we call it protocol adapters, and we are going off with the first protocol adapter called OPC UA. It's very popular in the manufacturing and industrial setup. From here, the two things will happen. Some customers can write their own protocol adapters, but we will be also bringing on additional protocol support. And then the last one is about having access to local resources. So one of the things we were dealing with originally when we designed Greengrass is if you download a function or download its code, what authorization do you give to access to the local resources? It could be USB port or hard disk or your volume or number of other devices that are there. And so the approach we have taken is from the cloud, you pick a Lambda function, you define what authorization you want to give or what access you want to give. So you simply pick a Lambda function. Actually, Jason will be able to show you a little bit. You pick a Lambda function and you define what resources you are available. And then, wait, there's more. And then this is the topic of the session today, is we are extending now the Greengrass device to make it simpler to run the machine learning model, and we'll dive deep. This one is a preview available as of yesterday. So let's look into this. Now, one of the things that, as my personal experience, and some of you have also had the same experience, when you build these systems, and if you were to, these distributed systems, we were to send all the data to the cloud and back, there's a lot of waiting has to happen, and a lot of, whether it's a latency or some of the cost. So the motivation for us is to enable number of solution that you don't have to wait, and you can enjoy that, accelerate that action that needs to be taken locally. So let's look at some examples for what I mean. First, you may ask, okay, what can you do with machine learning at edge? My actually first answer is, it's really your imagination is the limit. You could do what you want, and there are different systems would do different things, but I'll pick some examples, and you'll see some of our customers will talk about a little bit more detail. But simple things like what we have, think about agriculture companies during harvest, whether it's the fruits or any other produce, applying machine learning to quickly sort out what's the good, bad, or classify different produce. You can think of corn, you can think of apple, you can think of a number of things. But it will happen right there as opposed to hauling everything back in the processing facility and you do it there. The other example would be, actually there's a demo, if you have time, on the first floor here. There's a company called KUKA Robots. So one of the examples you will see there is not only Greengrass can be applied to during the manufacturing and apply the logic to different things that are happening, but towards the end of the manufacturing process, you can use either X-ray or camera or any number of techniques to see if the product that you're producing is the right one, or do you want to discard them. So you could think about that. Self-driving cars, any number of anomaly detection. I talked about securing your system through Device Defender, but imagine all this data coming in and you're analyzing it using this at your setup, local setup. So from here you can actually imagine what your application would be. For me, creating a smart camera, I put it on my driveway, then it knows that it's a family member, known car, and that doesn't bother me. Today, all my cameras just keeps telling me every time there's a motion, it tells me there's a motion, but I don't want to know that, right? So from the day one, you could train this camera to recognize certain things, and then only the events it has not seen, the events you're interested, that it tells you. But these are some examples, not necessarily, you obviously have a lot more interesting example than I have here. Okay, so how do you make this system intelligent? So we looked into the problem statement. If you were to do a machine learning today, you would start with a building and training a model in the cloud, which is a compute-intensive job. And so you start there, and then most of the application you will write the inference, meaning the prediction through the model, also in the cloud. So you can ask a question, and all the steps that you're doing is in the cloud. So the most, largely all of the machine learning that you are experiencing today, it's done through the cloud. But what are the problems with that approach? Obviously, you can't send all the data, so there's a cost associated, there's a latency, sometimes privacy. So what we have done is, Greengrass machine learning inference is actually taking a slightly different approach to this problem. So first, that step around building and training the machine learning model, which is a compute-intensive job, you would still do in the cloud the way you have been doing. The part that we have added to make it simpler is, if you're, as many of you raise your hand that you're familiar with Greengrass. So Greengrass has a concept of Greengrass group. You package what different things that you're managing, the Lambda functions, and also we call it the routes. So what we have extended the Greengrass capability to understand different type of resources, and Jason will explain how those local resources and machine learning resources work. But simply at this level, you use Greengrass to package the machine learning model in the framework, and use with the simple clicks you deploy on the device. And once that's deployed in the device, this model will run independently, whether it's connected or not connected. And that's where you inferring the inference for the application that you're running will be taken right away on the device itself. And our hope is this accelerates not only the different use cases that you're building, and then you would deliver a better experience to your customer, but it will accelerate the overall action taken. And as I talked about, you could build a system that can continue to function even if it's not connected to the internet. Okay, it's in a preview state, so we'll give you links later in the session where to go and apply for it. Now, beyond the 3-4 steps that I talked about, but once you deploy it, obviously your system is not perfect and you are going to evolve. So step from training the model, building the model and training it, and deploying it. And once you deploy, you're going to learn. So then you take that learning and the new data, and you want to feed back into the training model and come up with a better model, and then maybe an improved inference engine, and then you want to ship it again. So this whole cycle is I think is the most difficult part today. There is all the steps that I described, you can actually do it without the machine learning and inference. But what we are hoping to achieve is this: as a developer, you will be going through this cycle. Also, after you have deployed the system, you may have the need to improve. So I would like to invite our customer, SONY, who have experienced this problem of starting at a basic model and improving it. So please help me welcome Takehara-san from SONY, who will help us describe their use cases. Thank you.
Hello, everyone. My name is Ryuji Takehara. I'm a cloud system architect in SONY Network Communications. Thank you for giving this great opportunity. Today, I'd like to talk about our factory use case. We have using Greengrass to factory in order to collect actual sensor data from manufacturing machine and getting machine status on real time. It works very well. And now we will introduce Greengrass machine learning inference. So first use case, we have developed factory operator positioning, local positioning system with Greengrass and self-customized machine learning model. But now, major machine learning library takes more than 100 megabytes, and Lambda has size limitation. So it is hard to deploy a machine learning model with Lambda. And second use case, we are developing predictive maintenance to each manufacturing machine. So there are so many manufacturing machines in factories. I like to adjust and detail, customize a machine learning model for each manufacturing machine. But it is hard to handle hundreds of customized models and deliver it. And another point, to achieve practical anomaly detection with acceleration sensor, we need high-frequency sensor data, at least more than 10 kHz. So current cost efficiency programmable board don't have such ability. So it means we need some special hardware integrations. Today, we can solve these pain points with Greengrass machine learning inference. So new Greengrass provide and deploy our customized model to the edge side without size limitations. And we can do continuous adjustment and customization for each Greengrass group easily. And new Greengrass Lambda can access hardware resource directly. So to get high-frequency sensor data, we will introduce a new SONY programmer board we are calling Splitzer. And look at the graph. We can take high frequency data and make FFT convert, and new Lambda can access and integrate with new hardware directly. So I think how to make cloud and edge-heavy machine learning collaborative system is hot discussion topic until yesterday. But today, discussion is over. Anybody can make edge and cloud connected machine learning solution with Greengrass machine learning inference easily. So today's focus points are who can integrate, fully integrated sensors, devices, firmwares, edge-side machine learning model, and cloud-side model, and cloud-side applications. So IoT fields needs detailed adjustment and customization. We at SONY, we have good experience about customization of firmwares and edge-side machine learning model. So we will provide total machine learning solution, not only for factory, but also for many other IoT fields with Greengrass. Thank you very much.
Thank you, Takehara-san. Let's see. So one of the things that we are also trying to achieve through Greengrass machine learning at Inference is not all the developers need to really know all the intricacies involved in machine learning. So, or one of the other hope is that even if you don't understand the machine learning, you could still take advantage of having machine learning models developed by third parties and use this mechanism to deploy it. One of the other things that I wanted to point out is, as you think about pushing intelligence at the edge, these are the reasons we think of why this is valuable to do certain things. So for example, latency. The speed of light is constant. So if you need to take a decision very quickly, you want to put the decision as close to, you want to put that intelligence and inference as close to the system, as close to the data. The second is the bandwidth, depending on where you're deployed. In some of our customers either have constrained bandwidth because of remote location like mining site or oil rig. So you have limited bandwidth, so there's also it helps. Availability of the system, we talked about internet on and off. And then the last piece is the privacy. So depending on where you put the system, certain data cannot be transferred from one location to another because of the regulatory requirement. So one of our customers actually face all of these issues. So I would like to invite Kamis from Nokia to help us explain their use cases. Kamis. Thank you.
This one?
Yeah, that's for the clicker. Yeah.
Thank you so much. My name is Kamis, and I am the product manager for Nokia's Impact Video Analytics product. Just a little bit about the product. What it does is it examines IP video feeds and learns, uses unsupervised machine learning over time to determine what's normal and not normal from a motion perspective along dwell, density, velocity, and direction, right? Let's talk about what an anomaly is, right? Here's an example of a real video that we captured in one of our scenes. This is an example of a road that our product learned that typically goes north and south. And if you notice, there's a guy in the bottom that's deciding to make a U-turn right in the middle of this 6-lane road, right? Definitely an anomalous occasion. And because my product has learned that that's normal, it's able to flag that to the users about the event. But let's talk about traditional video analytics. The video cameras can can transmit up to 10 gigabytes of data per day. And if you are transporting those cameras over a local area network, that's really not a problem. So a campus or an enterprise or along an airport, you can send all those video feeds to a large server to be able to process and store all of that video, all right? The problem is, when you scale this out to a wide area network, it just doesn't work, right? You don't have enough fiber in the cities or enough of cellular connectivity to be able to transport 10 gigabytes per day per camera across that wide area network back to that same large server for the analytics to then result in, say, 1% of relevant data for the users, right? So the solution is actually quite simple. All we need to do is put that analytics at the edge, right? If we're able to put those analytics functions near the edge, we can view that constant video stream. My product will learn what's normal, and using Greengrass, I'm able to apply machine learning inference down to the node to be able to classify what's happening in the scene, right? Now what you're doing is you're drastically reducing the amount of network traffic that needs to move from that camera, or more appropriately near that edge device, back to the central place to, again, result in that 1% of relevant data for the users. And this is achieved by a combination of my product and as I said earlier, the Greengrass's machine learning inference to be able to push down AI-based object classification down to the edge to then communicate with my product for providing metadata analysis for what's going on. So if my product says that there's something strange from a direction perspective, then we can rely on these object classifications to tell me it was due to maybe cars going the wrong direction. All right? So thank you very much. I hand it back over to Satyam, Dr. Jake.
Thank you so much. So hi, everyone. I'm Jason Chen. I'm a principal product manager on the AWS IoT. So first, I want to thank you, Nokia, thank you, SONY, for giving us the opportunity to work on their use cases. Those are wonderful, interesting use cases. We had a lot of fun working on those things. So you guys have heard Satya talking about machine learning inference at edge, and now you know why it matters. And you also heard SONY and Nokia talk about their use cases, and you have seen the end result of using Greengrass machine learning. So maybe you're wondering, how do we actually implement those? What are the steps you have to go through to deliver this? So in the next few minutes, I'm going to give you those details. You will see we made the whole process very simple for you to enable machine learning on the edge. But I want to start by giving you the big picture. So when we say machine learning inference at edge, there are actually three things happening here. Right? So first thing is the device is doing sensing. What that means is the device gets a lot of data continuously to monitor the environment. Right? That generates a lot of data you need to process, to analyze, and one way to do that is machine learning. This can be you detect somebody's face, a VIP walking to the store, you detect that's a face. It can be detect some kind of pattern, the network is not behaving right, or if it's autonomous driving car, you continue getting a video feed and you see a stop sign and you need to recognize it. So those are the inference. Then based on the inference, the prediction, now you need to take action. So if it's autonomous driving car, you see the stop sign, maybe you need to send a signal to the brake to slow down. If it's a machine is about to break down and you detect that, you must send the signal to the device nearby to shut down that machine. So Greengrass is already giving you the capability to do those things, right? It helps you to sense because it connects with different devices and sensors and send data to the cloud or processed locally. And because we are using Lambda function, it lets you process data and take action on those things. But until now, injecting machine learning into this sense, inference, and action is not that easy. Let me tell you a little bit more about why it's not that easy. So the reason it's not that easy is there are so many steps involved in machine learning end-to-end. Right? The first step starts with data. You collect all those data, and you need to move them to the cloud. Right? There are a lot of data. You need to formatting them. You fill them. Then you send to the cloud. It's problem number one. And number two is once data is in the cloud, then you need to process them, and you need to do machine learning training, right? So in that step, you usually pick a training platform, you pick a algorithm, then you feed data to those algorithms to start building your model. Then your model is ready. Now you need to test it not only in the cloud, but on the device. Then you need to move that model onto the device to check the ground truth. Now, step number two and step number three, it's an iterative process. Right? You train, deploy, see if it works right, then tweak it. So it's a repeated process. Up until now, moving the model from the cloud to the device is not easy. If you want to do it by yourself, there are a lot of blockers. The model can be too big. And if you do it frequently, like a few times a day, like the use cases in SONY, then become a tedious if you want to do it manually. So up until now, there hasn't been a managed, reliable way of moving the model, cloud trained model, onto the device. Now let's say even you finish this step, you solved that. The next step is you have to bring down the machine learning framework also onto the device so it can parse the model for you. Right? When I say machine learning framework, that means things like MXNet, TensorFlow, Caffe2, Torch. So those are the mathematical libraries that understand the model and parse them so you can run on the device to do inference. Then there's another step that is your application. In our case, is you write Lambda function to load the model, to go forward pass, to do the prediction. If you change a framework, then you have to relearn some of the common tasks like loading the model, how to do forward detection. And lastly, there are more and more device vendors putting machine learning accelerators onto the device, for example, FPGA, GPU, or even DSP to help you make machine learning faster. Up until now, you need to write code to access those hardware accelerators if you're using Lambda. But all those things putting together can make your life of machine learning on the edge a lot harder, but we don't think it's necessary. That's why we introduced the machine learning inference on Greengrass to help you with those processes. So how we do it? Right, let me draw the big picture for you first. Again, so number one, you train in the cloud because cloud is the natural place for training. The reason is training requires a lot of computing power to do mathematics operations. And it has a large depository for data. All your data stays in the cloud. And also cloud is the place provide you a lot of memory. You need a lot of memory to keep the state during the training process. So cloud is most likely for you the right place to do training. Now once you're trained, you need to move the trained model onto the device so you can get those benefits Tian was talking about, right? Low latency because you process right there. You save bandwidth, like in terms of a Nokia use case, you don't really need to send it all the way to the cloud. And your data always stay with you if you're concerned about privacy. And also, it can happen offline because you no longer rely on the cloud. So Greengrass tie everything together for you. So tie the cloud training and deploy of the model and local execution, those just giving you the infrastructure to tie those pieces together. So you install Greengrass on your device. The Greengrass let you to move the cloud trained model onto the device, also move your inference application, which is Lambda in this case, onto the device. Now they can do the three things I was talking about locally on the device: to sense, to infer, and take action. And if you have more interesting data or intelligence after you process, you can upload them to the cloud if you want to. Okay, so let me get into some of the details on how exactly we do those things, right? So first, you need to train your model in the cloud. You can actually train anywhere. All you need to do is point Greengrass to your cloud trained model. And you add that as what we call machine learning resource to that Greengrass group. I will do a quick demo later to give you a better sense. Now, if you are using Amazon SageMaker for training, you probably heard that yesterday, then it's great because Greengrass natively integrates with SageMaker. In the Greengrass console, you can see all your SageMaker trained model, and you can just pick the one you want and add that as a machine learning resource, and the Greengrass will bring it down for you. Now, if you don't use SageMaker, if you train somewhere else, or if you have pre-trained models, that's fine. You just need to place it in S3 and let Greengrass know the URL of the S3, and the Greengrass will take care of the rest for you. Another thing I talked about, which is accelerators. Those things are like a CPU and a GPU, DSP. So up until now, it's hard to directly access those things from the Lambda function. You have to write a chunk of code. Now with the local resource access functionality provided by Greengrass, it works nicely. Now you can just define, you say, okay, here is a GPU, and I'm giving the path to it, and now you can access it in the Lambda function. And number three, remember I said about building your own MXNet is not easy. Or building any kind of ML framework from scratch is just not easy, right? You have to know a lot about the hardware profile, and you have to compile by yourself. It's a tedious process. It takes you many hours, if not days, to get it right for a specific device. So what we provided for you is a pre-built MXNet package. So you have the environment ready for those devices. So one is the Intel devices, Atom devices. It's also known as Apollo Lake. We have the NVIDIA, and we pre-built for Raspberry Pi. You can always bring your own framework if you want to build it by yourself, and you can certainly bring that onto Greengrass. It will still run. We just make it a little easier for MXNet. And the next one is we also provide you Lambda inference examples, because we realized that it's not easy if you haven't done that before, especially with a new framework and to run that on the device. So we provide some examples for you so you can follow, and that example do some of the common tasks, such as loading the model into the application, and how do you run a forward pass to do the detection. So with those things, your life of creating inference app will become easier. Okay, so now is demo time. Let me do a quick demo so you get a better sense on how to use those and why it's so simple. All right, so what I have here is the Greengrass console. I just log into the Greengrass console. That's where you see all the defined Greengrass groups. So for you guys who haven't used Greengrass group means there's a Greengrass device, and there are a bunch of devices connect to it, and they form a group. And what you define in the cloud is basically what's going to run on a Greengrass device, right? What kind of access it has, what kind of Lambda function it will run, and also you can define other things like a communication rules, like a device A can talk to device B using MQTT, what subject they should listen to, and when certain things happen, what kind of Lambda function should be launched, right? So you define all those things in the cloud, and then deploy to the device, then device will execute basically what the cloud says. Okay. So I'm going to pick this group, which is already created. That is my camera device. Right? And I wanted my camera device to look at image, and I want to run machine learning on my camera device so it can recognize things. So what you need to do here is basically tell the camera device, in this case it's a Greengrass device, what things you need to run. Right? So there's a Lambda you need to run. That is your inference app. And I want to show you here quickly, here is the resource. That's what we have been talking about. One is machine learning resource. That's like your cloud trainer model. And you can also define local resource, for example, GPU, FPGA. So we start by configuring the Lambda function. I have one already uploaded into the cloud. That is our inference app. So this Lambda function will take the image and take a look and detect if this is a certain type of image. So it's configured how much memory it should use, timeout, etc. But what's interesting is we need to add resources for this Greengrass group, and so the Lambda function knows like which resource it can use. So in this case, I'm going to add machine learning resources. So my Lambda function, as I mentioned, is doing image recognition, but for it to do its job, it needs the models. Right? So in this case, I'm going to define two models because I'm doing A/B tests. I want to compare those models. And one of the models is the training job I'm doing in SageMaker. I'm using a ResNet image. So this seems is the latest training job finished. ResNet is basically a image recognition model. Right? So I picked the trainer model in SageMaker, and here I'm basically defining when the model gets down, what is the local path or local directory for that model to stay. Let's just put in there, say, model ResNet. Okay, let me give it a name. Let's just say ResNet. And it's saved. All right, so I have one resource defined. That resource is a cloud trainer model. Now let me add another one because I said I want to do A/B test. All right. And this time I'm just going to add a model that is pre-trained. It's called a SqueezeNet. For those of you guys don't know, SqueezeNet is a super small compressed model. So it can run on smaller device, but still maintain pretty good accuracy in terms of image recognition. So this is in S3, and I still say I'm going to put locally here, and I'm going to give SqueezeNet, put into that directory, and also give this resource a name. And save it. Right? So now I'm done. Right? I'm saying I have added those two models into Greengrass, and this Lambda has access to those two models. Go back. So what's the next step? The next step is deploy. Right? So since we have a short time, I'm just going to show you that's what you define in the cloud. And once you click deploy, my device in Office will receive this deployment. It will include that Lambda function, which will do the inference, and it also will include the models that will pull down from the cloud onto the device. Then it can start doing sense, infer, and take action. So let me just summarize what I just described for you for Greengrass machine learning inference. Number one, you can train the cloud. The Greengrass can deploy cloud trained models for you, so you don't need to do that by yourself. And number two, it allows you to access hardware resource such as CPU and GPU and FPGA, DSP, et cetera, to help you do accelerating your inference. And the third is we pre-build, pre-package MXNet for you, so you don't have to build by yourself. So you have an environment that is prepared for you. And lastly, we give you some Lambda function examples, so you can follow those examples to write your own inference applications. Guess what? There is one device with a bunch of good software that enjoys all the 4 benefits I just talked about. Right? So this is AWS D-Plans. It is a video camera that has computer vision models that you can run on the device. So this is a collaboration of AWS AI team, Greengrass team, and our partner, Intel, because this device runs on Intel platform. So it is, I like D-Plans because it's a good proof that if you have combined device, good edge software, and a cloud together, it just does amazing things for a customer. So we feel very lucky that during those long journey, we have many good partners working with us, innovating together. And one of them is Intel. They have been with us as a partner since the very beginning of AWS IoT. So it is my pleasure to introduce Naveen Law from Intel to talk a little bit more about Intel and AWS collaboration. Thank you, Naveen.
So yeah, thank you for the intro. It's been a real pleasure working with the team at Amazon on getting this product out. Just to kind of give you a little bit of a background and context here. This product was really conceived about 6 months ago or so, and now we're bringing it to market. So I think that's got to be some kind of a record. It's incredible. It's an incredible effort on both sides. The AWS team and getting the Greengrass software to a point where we can actually deploy it and interact with our team to find the optimized libraries with CLDNN, get efficient inference working on this platform was an incredible effort. And then on the hardware side, we were able to take a very stable platform and build off of it very quickly. So this is, I think Jason hit on most of the points here, but because we're working from a stable, rock-solid platform that we can actually move the containers and things around easily, it makes it easy for the software teams on the AWS side to actually build this device and make it robust. And as part of that, it actually delivers a secure security as well as intelligence to the edge. So they can manage all of the encryption and things like that because we have the hardware on board to do so. It's already been tested. The hardware here also has an integrated GPU and integrated video compression logic. So it's ideal for this kind of case. And what I think is really cool about D-Plans is that it's a kind of turns this into an application development problem. Now, when you have a camera that you can stick into the world, you can build any kind of application, right? I mean, if you want to build something that's, that monitors factories or build something that monitors your pets, it's the same piece of hardware, and now we have the software to actually stitch it together with the cloud and build those applications. And so just a little bit about the Atom processor. You may have heard it in the other keynote this morning. It is integrated graphics, and we actually worked quite hard to get the deep learning primitives optimized and hooked together with the rest of the Greengrass software. And so, again, a wonderful effort on both sides. And you know, some of this was also about making sure we can fit into the power envelope. So, you know, the hard part about hardware is always you're building something in the real world. It's got to work, you know, when it's hot and it's cold and under the right kind of cooling conditions and heat, you know, these kinds of things. And so we want passively cooled. It can work in a variety of environments. And so at Intel we had the hardened chips to be able to serve this purpose. And so yeah, I just want to congratulate the team on getting something out so quickly. It's an amazing effort. Thank you. Thank you.
So as Satya talked about the journey of IoT, the first stage is we get IoT connected to the cloud so you can move the data securely to the cloud. Then we enter the phase of managing those devices. I think really now we started to enter another new phase, that is you want to bring intelligence onto those devices. So combined with the power in the cloud, you make your device a lot smarter by running AI and machine learning on the device. And Greengrass, the software runs on those edge devices, make it a lot easier for you to run those machine learning inference on the edge devices. So we have been very lucky. I have many customers and partners who are with us in this journey. So we are innovating together to bring intelligence onto those devices. So they let us solve their use cases and work with our partners who combine device and software together to deliver interesting, good use cases. So Greengrass Machine Learning Inference is in preview now. Yesterday, actually started yesterday, you can apply here. Just go to this website, Amazon, aws.amazon.com/greengrass/ML, apply for preview. We would like to hear you using it, and we would like to hear your use cases, and we would like to hear your feedback. And here's a little bit more. There are a few things I want to give a shout at. The D-Plans, they are still running workshop today, and you can go there and try it out. And Greengrass is the backbone behind the scene, providing those infrastructure, glue them together. There's a flight simulator up on the Build-A-Sphere, and also use Greengrass to do machine learning over there. There's an echo greeter. There's a dynamic sorter, which is an interesting one in the Build-A-Sphere. It actually uses Raspberry Pi, but it recognizes the recycling object. So if it's a can, if it's a box, and if it does recognize the pre-selected list of recycle object, the arm will move put that object into the right bin. Right? All those things are done on the machine locally. Satya talked about the industrial robotic arm, which has Greengrass running. You should check it out. And also in the maker's place, there's the Nokia use cases you guys can check out. We have the camera and also the Greengrass and the Nokia software running together. Okay, that's it. Thank you very much. Yeah, we can take some questions. We have 6 minutes left, and if folks have questions, we are happy to take them.